Welcome to this e-lecture, which will be about the univariate analysis and measures of variability or variation. So, what is measures of variability or variation? Well, it's the amount. These measures provides us a measure of the amount of variation in the observed values on a variable. And I will first introduce you to three measures that are a bit hard to understand and to get a grasp on, but I will tell you how I use the standard deviation mostly. I will show you the sum of squares and the variance because these are important parts of how to calculate the standard deviation. But I mostly use the standard deviation as a measure of variability or variation, and we'll also learn about range and interquartile range, which are two measures, other measures of variation. So, okay, the sum of square is the sum of square deviance from the mean. That's the sum of squares. But the average square deviation and the variance is the average square deviation from the mean, arithmetic mean, and the sum of squares divided by the number of observations. And the standard deviation is the squared root from the average square deviation from the arithmetic mean. So yeah, these are all the square, sum of square and the variance goes into the calculation of the standard deviation. I'll show you shortly how this is done. And the range is the difference between the highest and the lowest value, and the interquartile range is the range from the lowest, when the lowest 25% and the highest 25% of the values are excluded. So it's really the range between the 50% in the middle of an ordered distribution. Okay, so let's look at the sum of squares. These are seldom used as a measure of variability in itself, but it's a starting point of two central measures of variability, namely the variance and the standard deviation. And as I told you before, I mostly use the standard deviation. And the difficulties is that it increases with the numbers of observations, and it's really sensitive to extreme values. And the procedure is that you calculate the mean, and then you calculate the deviation from the mean for each observation, and then you square this deviation, and then you take the sum of the square deviations. The variance, the sum of squares increases with the number of observations. By dividing the sum of squares by the number of observations, we measure the amount of variation around the mean. So that then you get the variance. But the difficulty with the variance is that it has no simple or intuitive interpretation, and the variance is highly influenced by extreme values. So that's a problem with the variance. The standard deviations, well, the variance is measured in squared units, for example, squared dollars, squared years, etc. But by taking the squared root of the variance, we offset the squaring of the deviations when calculating the sum of squares and retrieve the original measurement units. So then we get the measure of the variation around the mean. And the difficulties is that we have no simple or intuitive interpretation of the standard deviation, and it's very sensitive to extreme values also. So, okay, how do we calculate the sum of squares, variance, and the standard deviation? Let's look at an example. These are here. We have a calculation of the standard deviation for 10 randomly chosen countries, and as you can see, the mean life expectancy is 68.2 years. The sum of squares are 921.6, which says nothing really. The variance is 92.16, which is also not very easy to understand. But the standard deviation, when we take the square root of the 92.16, we get 9.6 years, which is the standard deviation around the mean. So what does this say? Well, first of all, foremost, it says something about variation around the mean, and as we can see here, there is quite a lot of variation in the life expectancy among these 10 countries, because you have it's from 48 up to 82 years, which is quite a huge difference. And you have 56 and 70 years and so on. So it's quite a lot of variation. And I would say that 99.6 years around the mean of 68.2, I would say, okay, there's a lot of variation in this data. That's the first thing the standard deviation tells me. And the second thing you can use the standard deviation to say something about is whether there is a outlier there, because if you get a really high standard deviation, you can really say that, okay, this is a huge standard deviation. I believe there are outliers in my data, so you can use it as a warning that there is an outlier. You need to be aware of, or several outliers. Okay, so we have the range. Well, that's the difference between the highest and lowest observed value in the distribution. And if we look at the our total distribution of life expectancy, it goes from 83 to 41 years, and it's then the range is 42 years. And it's very sensitive to influence from outliers, because I mean the outliers goes directly into the calculation of the range. But then you have quartiles. If you find the values, quartiles, that divides an order distribution into 4 parts with an equal number of units, you can calculate the difference between the first quartile and the third quartile. So you exclude the values, the 25 lowest and the 25 highest, and you just take the difference between the 50% in the middle. Then you get a measure that is less sensitive to outliers than the range, and you eliminate the influence from the lowest and the highest values of the variable. And you can calculate the interquartile range by using the frequency distribution. And here we see that we find using the cumulative percentage, we find the place where the 25% is, and that's 61 years, and 75%, that's 75 years. So there you have the first and the third quartile, and you take 75 years minus 61, which is 14 years. So that's your interquartile range. Okay, so if you want to compare range and the interquartile range, well, the range is the difference between the highest and lowest observed value in the distribution. So it's 83 minus 41 years, which is 42 years, and it's very sensitive to the influence from outliers, because, as I said, the outliers go directly into the calculations, because if 83 years was an outlier, then I mean, or you take the highest and lowest value, and then I mean, by definition, outliers are in the highest or the lowest values. And then you have the interquartile range, which is the deviance between the highest and lowest value when we exclude the quarter of the observations with the lowest values and the quarter with the highest values. So then it's 75 minus 61 years, which is 14 years. And that's very robust, or relatively robust, against outliers, because we exclude outliers. So that was the e-lecture about measures of variation. Thank you.